demonstration video. Let's go ahead and jump in and get started.
This is application 4-1 geometric sequences. Our learning target is that I understand that sequences are a function with a domain of natural numbers. So let's jump right in and take a look at your application. We are going to look at problem number 1. A culture of bacteria doubles every hour. Mr. Bolton checks the bacteria every hour and records the amount of bacteria. If there are 500 bacteria at the end of the first hour, how many bacteria will there be after 24 hours? We want to write the problem as a sequence, state the common ratio, and write an explicit formula to find the answer. So let's go through and highlight first our important information. So we know that the bacteria doubles every hour. We know that Mr. Bolton checks it every hour. We know we started with 500 bacteria at the end of the first hour, and we want to know how much bacteria there will be after 24 hours. We want to make sure we write the problem as a sequence and state the common ratio and write an explicit formula to find the answer. Okay, so if we just wanted to sketch out what this would look like as a sequence, we know our first hour is going to have 500. Alright, if we double that, our second hour is going to have 1,000. Our third would have 2,000. And we could keep going on with that. Now, if we were to label these in terms of sequences, this would be our a sub 1, our first term. This would be our a sub 2. This would be our a sub 3, second term and third term. And we keep going on until some a sub n. Now, we could do this 24 times and figure out what we would have after 24 hours, but that would take an awfully long time. We have a shortcut we can use, the explicit formula. It's going to help us find that a lot quicker. But to do that, we also need to have the common ratio. The common ratio is what we're multiplying it by every time. Now remember, we said doubles every hour, and doubling means that we are multiplying by 2. So R is going to equal 2. Now, if you look at your formula sheet, remember all your sequence formulas are on your formula sheet. They're at the beginning of this packet, and as well as around the classroom on the desk, or if you need one, see Ms. Blaylock or I or Ms. Smith, and we'll get you one. Alright, but our explicit formula for a geometric sequence is that a sub n equals a sub 1 times r raised to the n minus 1 power. Remember, a sub 1 is our first term, and r is that common ratio we just found. So we are going to plug in. We're going to leave a sub n. Remember, a sub 1 is our first term. Our first term in this problem was the 500 bacteria at the end of the first hour. Our common ratio is going to be 2, and we're going to raise it to the n minus 1. So this would be our explicit formula. Alright, the last thing we need to do is figure out how much there would be after 24 hours. So what we are going to do is we're going to plug 24 in for n. So a sub n is going to equal 500 times 2 raised to the 24 minus 1 power. And of course we know that 24 minus 1 is 23. So I'm going to type that into my calculator. And when I type that into my calculator, I'm going to see that I'm going to get 4,194,304,000 bacteria. So we can see that bacteria grew very, very quickly, and you're going to find that that will happen a lot with exponential functions. Alright, so that wraps up problem number 1 from your application 4-1. Make sure to complete your entire application 4-1 and prepare for your mastery check. And then go ahead and schedule your mastery check with your teacher, and good luck on that. We'll see you in the next video.